Hi all, it's Brendan, and I'm going to be doing 30 days of Solidity, day 4, and I'm going to be doing an auction house. So this is what it looks like, right, in the calendar. So one, right. So we'll create an auction. Users can bid an item. The highest bidder wins when the time runs out. So I'm thinking over here that we keep track of two state variables, one for highest bid and one for the address of the bidder that made the highest bid so far. And then when the time runs out, so I'm thinking in the constructor, there should be a timestamp that's stored of whatever the current block timestamp is, right? And added to it a duration, a number of seconds. And then the if statement would just be used to store if it is the current highest bid, otherwise it just doesn't do anything. And then we would need like an additional function at the end to retrieve the winner, but the winner can only be retrieved at the end of the auction. Alright, as before, I've copied the description over here, right, into the comments, and created an empty smart contract just to speed things up a bit. Alright, so let's begin. So I'm going to have some state variables here, and then just jump straight into the constructor. So end timestamp is equal to block.timestamp plus duration. I am going to have a duration, so event 256 constant public duration, and let's set it to 30 seconds, right? It's constant? Yeah, okay, constant public duration is equal to 30 seconds. And then next up, I can do the end timestamp. Event 256 public end timestamp, and I'll just not initialize it because it's going to be initialized in the constructor end timestamp. All right. So when the contract is deployed, I will immediately have an end timestamp, which will be 30 seconds later, and so the auction automatically starts upon deployment. I could get more complex. I could have like an owner, and then the owner can start and stop the contract at the auction, etc. But that's I guess going a bit further than the requirements of this. I'm just going to use the deployment time as a means to demonstrate this auction capability. All right, so the next thing I'm going to do is a bid function. So this is the main thing that multiple users are going to be calling. So UN 256 amount and the public, and then I would say if the amount is more than highest amount, so that will be a new state variable, highest amount, then I would do two things, right? I would update highest amount equals to amount, right, that was sent at the bid, and then the other thing I would do is highest bidder is equal to message.sender, so the address of the person who sent or the account who sent it. So I'm using these state variables. Let's declare them. Highest amount would be unit 256, right? So and I'll initialize it to 0, and next thing would be highest bidder. I would actually declare these as private, so they actually are not private. Instead, they are readable. Private just means that it doesn't Solidity won't put an accessor method, but anything stored on the blockchain is public, right? It's just a bit more tricky to get to because you don't have the accessor method, but you can still read directly the values of any private variables in the smart contract, just because all the transactions and all the data on the blockchain are completely public. So the name private is a bit of a misnomer in this case. Okay, so UN256 private highest, what do you want to call it? Bidder, highest bidder is equal to address, and it'll be a 0 address. So I'll do 0x. That should do it. Sorry, the type is wrong. Address. Oops. Alright, so that should compile. Alright, and one more thing, I should say bids cannot occur once the auction is over. So require that block dot timestamp, the current timestamp, is less than or equals to end timestamp. And if that doesn't happen, then I should say cannot bid as auction is over, right? So once the auction is over, you try to bid again, the bid gets rejected, and this is what gets displayed as the error message. Next thing is function winner. So this is after the auction gets called, right? This will be public view, right? And so this one requires the opposite require statement. So block.timestamp, instead of less than or equals to, it can be more than. So it's only after the end timestamp. And then the error message, if you try to do it before the auction is over, so in this case less than 30 seconds after deployment, the error message will be winner is not certain until after auction is over. Alright, and I think I'll add one more require statement, which is that the winner can only be declared if there were any bids. So if highest amount is more than 0 and highest bidder is not equals to address, so it's not the 0 address, then I'll say that auction received no valid bids. No valid bids before it closed. Alright, now let's actually retrieve the values. Since this is a view, for it to be useful, I need to actually return two variables, right? So I'll say, let's see, I need to return the amount. So I'll say amount equals to highest amount, and bidder equals to highest bidder, right? And these will be return value scoped variables, returns, and then you went 56 amount and address highest bidder. Oh, sorry, not highest bidder, just bidder. Right. Okay, so that will return highest amount and highest bidder, but only if these two require statements pass through. So these all the conditions get met, then it returns. The other thing is that this is a public function, whereas these are private state variables. So this actually constitutes an accessor method for the private variables, and in doing so, it gates being able to access these variables through its own logic, i.e. these two require statements. Okay, and I think that's done actually. So we've already got an auction house that allows you to bid until a particular end time, and after which you're allowed to query and find out who the winner was and what their amount was. Very simple. Now, note that this auction house doesn't actually involve moving funds, right? So I'm not saying that any of these functions are payable. In fact, these functions are explicitly non-payable. So you can't say message dot amount or something like that. You can't access those values, right? And so the smart contract doesn't get paid when you make bids, for example. If I were to do that, however, then I would actually store the amounts in a mapping, right? Because then whoever doesn't actually put the bid in or doesn't win the bid, they get their funds returned to them at the end, right? That should be how it works. Yeah. So anyway, that's a bit of a preamble. So let's actually compile, and yep, that works. And then I'll go to the first address and press deploy. Okay, so I've got an auction house and I've got 30 seconds on the clock. So in my first account, I'm going to bid 1 bid, and then second account, I'm going to bid, let's say 10, and then third account, let's say I'm going to bid 5, right? And then let's call winner, and then because I've called winner before the auction is over, before 30 seconds, it'll say winner is not ascertained until after auction is over. Now, let's press winner again, and this time, because it's after 30 seconds, it'll say amount is 10 and bidder is this, right? So it was the second account which bid 10, right? So if you remember the order, first account bid 1, second amount bid 10, third account bid 5. So 1, 10, 5 and 10, 1. And that was the answer. Now, let's actually test whether I can bid again, right? So I'm just going to switch to, say, a fourth account, and I'm going to bid like a large number, right? And that's not going to go through no matter what the amount is, because it says cannot bid as auction is over. Right, so I've actually tested the edge cases except for this one probably won't happen. That's the most boring one, is where an auction doesn't actually do anything. Alright, that's it for Web3 Compass 30 Days of Solidity Day 4, where I have an auction house. Thank you for listening.